All right, we are starting chapter 8 today, doing direct and indirect variation. And we're going to start with direct. So when we talk about direct variation, what we're saying is both our quantities, our x value and our y, change in the same direction. So basically we're saying if the first quantity goes up, then the second quantity is going to go up also. But if our first quantity goes down, then the second quantity will go down also. Some places that you might see this is if you're going on a trip, right? We would say the amount of miles that you traveled will go up with the amount of time that you are on your trip. So distance is going up and time is going up, right? Or maybe if you're buying something, if you buy 16 ounces of candy, it's going to be $4. But if you buy 8 ounces of candy, it's going to be $2. Okay, so as your candy weight goes down, you spend less money, and vice versa. As your candy weight goes up, you spend more money. So that is how we deal with direct variation. And there's an equation for direct variation. It's y equals kx. And that k is always going to be a constant. Okay, so you can plug in any values of x and y, any point, essentially, if you think about it as a graph, any point that would make that equation true, where k is staying the same all of the time. Okay, so when we do direct variation, if we solve for k right now to see the relationship between our x and y, you have y equals k times x is your equation. If we solve for k, we would divide by x on both sides, and that would mean that k equals y over x. So our constant with direct variation is always going to be the y value divided by the x value. Okay, and we say we set up proportions to solve with direct variation because two of these, y over x equals y over x, in order to always make it equal to k, that's going to create a proportion. Okay, so just remember direct variation, when you're solving, you're going to set up proportions. So that's what we're going to do right now. This first one says, if 4 bottles of milk cost $2, how many bottles can I buy for $8? Okay, that's a direct variation. The more bottles you buy, the more money you're going to spend, right? So both are going up or both are going down if you think of it in the reverse order. So if we're setting this up, we can say $2 for 4 bottles should equal, okay, that's our y value over our x value, should equal $8 for how many bottles is what we're trying to solve. See, that's a proportion, right? So essentially you're solving 2 over 4 equals 8 over x, and with proportions we just cross multiply. So 2x equals 32, and then we'll divide by 2. So x would be 16 bottles. Okay, that's direct variation. As the milk amount went up, the amount of dollars also went up. Okay. Example 2, it says a phone call costs $1.20. How much does a 10-minute phone call, cost $1.20? How much does a 23-minute call cost? And if you think about it, the more time you spend, the more money you're going to spend. So this is also direct variation, where one is going up, the other is going up. So we're going to say a 10-minute call at $1.20 will equal a 23-minute call at what price? Okay, so that would be our x. You can technically flip those. If you did $1.20 over 10 and x over 23, you would get the same answer. So it's not a big deal if you flip-flop where they're at, as long as you keep the relationship the same. So keep the same, minutes on top and dollars on bottom, or dollars on top and minutes on bottom. So if we cross multiply this, we get 27.6 when we do this guy equals 10x, and then we're going to divide by 10. So we get x equals 2.76. Think about what we're talking about. We asked what's the call of that cost going to be. So this is $2.76 for a 23-minute call. Okay, so that's direct variation. Inverse variation is very similar, But now instead of both your quantities moving in the same direction, they're going to move in opposite directions. So basically we're saying if the first quantity goes up, the second one's going to go down. If the first quantity goes down, the second one is going to go up. Okay? So what we're doing with that is things like, if we're talking about a job, right? However many people you have on a job site, the time it takes to complete that job, if you have more people, it's going to take less time. If you have less people, it's going to take more time, right? So if the number of people is going up, the amount of time is going to go down. That's inverse variation. Or the speed of the car. If you go faster to school, you'll get there in less time, right? So speed of the car and the time it takes to get there would be an inverse variation. So the equation for inverse variation looks like this. When you do inverse variation, if we solve for k right now, so y equals k over x, if I multiply by x on both sides, I get k equals x times y, okay? We are setting up products. In other words, we are multiplying our x and our y every time with inverse variation, okay? The way you can think of it is this. You take your x1 times your x2, and it will equal, sorry, I wrote that wrong. Rewind. You take your x1 times your y1, and that will equal your x2 times, I keep wanting to say x, times y2. Okay, so you're going to set up products. We multiply when we are solving for inverse variation, which is weird because if you look at the equation, it's division, right? But we're solving for the constant. Well, in order to get that constant by itself, we have to multiply by x on both sides, which is multiplication. Same thing with direct variation. Direct variation, it looks like, no, we're multiplying k times x, but we want to know what k is. So we have to divide to get k by itself, okay? So make sure you're keeping those straight. Here's what we are doing with this. So example 3 here, it says you hired 3 people to paint a house, and it will take 2 days to paint the whole thing. How long will it take for 2 people to paint a house if one painter calls in sick, okay? So 3 people for 2 days, 2 people, how long it take 2 people if one of them calls in sick. So our number of people is going down, but think about what this means. If you have less people, it's going to take longer, right? So that's inverse variation, which we're going to do 3 people times 2 days, right? Products when we do inverse variation. So 2 people times how many days will be the other situation, because one of your painters called in sick, now you only have 2 people to work with. So simplify this, 6 equals 2d, and we divide by 2, so d is 3. So if we only have 2 people, it's going to take 3 days, whereas if we had 3 people, it would take us 2 days, okay? All right, example 4 here, it says 50 kids are going to camp, and they have enough milk for 10 days for 50 kids. Now, if 15 kids don't drink milk, how many days would the milk last? So think about this. 10 days for 50 kids, but now less kids drinking milk means more days of milk. So that's inverse variation because more kids equals less milk, right? So with inverse variation, it's products. We're going to multiply to get our relationship. So 50 kids times 10 days will equal, now it says if 15 kids don't drink milk. So how many kids are drinking milk then? Well, that's going to be 50 minus 15 of those kids. So 35 kids would give us how many days? Okay, so 35 times D equals 50 times 10. Simplify that. We get 500 equals 35D, and then we would divide by 35. So D would be 14.3 days. So if 15 of them didn't drink it, we'd get an extra 4.3 days out of the amount of milk that we had. Okay, so here's the overview. For direct variation, we're setting up proportions, right? It came from this equation. For inverse variation, we are setting up products. Okay, so this is products. This is proportions. This came from y equals k divided by x, inverse variation. Okay, so keeping that in mind, we're going to determine is this direct or inverse or neither, and find k, and then we're actually going to find the equation for the problem as well. Okay, so on this first one, if you look at your numbers, as we go down 0.5, 2, and 6, our numbers are going up, right? As we move down the side, 1.5, 6, and 18, those numbers are going up as well. So this is either direct variation or neither, okay? We can just see by looking at it, it's not inverse. Okay, so if it's direct variation, that would be this equation, y equals k times x. Okay, remember direct variation, if we solve for k, our k is always going to be y divided by x. So to see if k is actually a constant in this problem, we're going to take our y divided by our x, 1.5 divided by 0.5. If you plug that into your calculator, you get 3. Okay, so that's k on those first 2 points, first two numbers. Now do it here. My y value divided by my x value, also 3. Now do it here. My y value divided by my x value, also 3. When this is the same every time, that means k is 3. And if k is constant, if it stays the same number, this is a direct variation. Okay, so if this is a direct variation, then our equation, if we go back up here, we want to write our equation. It's going to be y equals 3 times x for this whole problem would be our equation. Okay, look at the next one. This one, your numbers 0.2 to 0.6 to 1.2, those numbers are going up. 12 to 4 to 2, those numbers are going down. So this is either inverse or it's neither. Okay, it cannot be direct variation if they're going in opposite directions. So think about inverse variation. Inverse is y equals k over x. So if we solved for k, that's x times y. Okay, so we're going to do that over here. We're going to take x times y. 0.2 times 12 is 2.4. Okay, now here, 0.6 times 4 is 2.4. And now here, 1.2 times 2 is 2.4. So because those all came out to the same number, my k is 2.4. That means when I go to write it in the equation, okay, this is, like we said, inverse variation because it's the same number. Okay, so this is inverse with a k of 2.4. So we're going to plug that into the equation. Y equals 2.4 divided by x. Okay. All right, next one. When you look at this one, 1, 2, 3, our numbers are going up. 2, 4, 9, our numbers are going up. So this is either direct variation or neither. Okay, and then recall what we did up here with direct variation, right? We plug it into y over x to see if they're the same. So y over x would be 2 over 1 and 4 over 2 and 9 over 3. Well, simplify that. 2 over 1 is 2, 4 over 2 is 2, 9 over 3 is 3. Because those are not all the same, it's not a direct variation. We don't have a constant. We don't have a number that stayed the same. So we would say this is neither. Okay. Okay, so let's try this. It says, suppose x and y vary inversely. Okay, x equals 4 when y equals 12. What would our equation for that be? So we know inverse variation is y equals k over x. Okay, and we know that to solve for k, we have to multiply by x. So our k is always x times y in inverse variation. So take our x and our y and drop them in. K equals 4 times 12, so k is 48. Okay, once you have your k, now we can write the equation. Okay, the equation would then be y equals, instead of k, we're going to plug in our 48 over x. So this is the equation for that set of information. So then it says find y when x equals 7. Well, all we do is we plug that in. Y equals 48 over 7. That means y is 6.857. Okay, so that's inversely, right? Now it says suppose x and y vary directly. Remember, direct variation, the equation is y equals k times x. We have to divide by x to find our k. So our constant, our number that's going to stay the same in the problem, is y divided by x. Well, y is 3 and x is 10. So k is 3 over 10. Okay, if that's the case, we're just plugging that in right here. Y equals 3 over 10 times x. All right, so that's going to be your equation. Then it says find y when x is 50. We're just going to plug a 50 in. So y equals 3/10 times 50. So y equals 3/10 times 50 is 15. Okay. Okay, now we get a little bit fancier. This is combined variations, and this will say a little more information, okay? Now, whenever it says varies jointly, that's direct, okay? So z varies jointly with x and y. You have to make sure you're always putting a constant in. There's always going to be a k in these setups. So we would say z varies jointly, okay? So our k times direct variation of x and y, that will be your equation, okay? This one says z varies jointly with x and y. So z varies jointly with x and y, and inversely with w. That means divide by w. So that would be your equation for that one. Okay, last one, z varies directly with x. So z varies directly with x, so that's k times x, and inversely with the product of w and y. So inversely divide by the product of w and y. So it's going to look like that. Okay, so we're going to do a few of those. This one says z varies jointly with x and y. Okay, so write that out. Z varies jointly, so k times x times y, right? Varies directly when it's varies jointly. So z equals k times x times y. And then it tells you z is 28, x is 7, y is 2. So plug those in. 28 equals k times 7 times 2, okay? If we simplify that, 28 equals 14k, divide by 14, so our k is 2, okay? We need to write the equation. All you do for this is you find your k and you drop it in to that original setup. So this is z equals 2 times x times y. Okay, that's our equation. So then it says find z if x is 6 and y is 4. So z equals 2 times 6 times 4. That means z is 48. Okay, last one. This one says z varies directly with x and inversely with the square of y. Okay, so z varies directly, don't forget your k, with x. Inversely means we're dividing, and then the square of y, so y squared. Okay, they tell us what x is, they tell us what y is, they tell us what z is. So plug those in. Z is 50 equals k times x, which is 35, over y squared, 7 squared. Okay, now we just solve for k. So this is 49. We're going to multiply by 49 on both sides. So 49 times 50, we get 2,450. This simplifies to 1. And then we just have 35k on the other side. And we're going to divide by 35. So our k value ends up being 70. Okay, so we take our original equation and we drop the k in, the 70. Should have done that this way. So the equation is z equals 70 times x over y squared. So we can use that for any set of numbers in the problem now. So now it says find z when x is 5 and y is 10. So 5 is going to go here, 10 is going to go here. So z equals 70 times 5 divided by 10 squared. Okay, so that would be 350 divided by 100. So z is 3.5. Okay, that is direct and indirect variation. Have a lovely weekend.